Welcome to Electrical Engineering with Excel. In the previous video, we wrote some VBA code to select the closest standard component value from the E96 series. In this video, we will expand that code to make it work for the entire group of E-series preferred numbers for standard component values. We wrote some simple VBA code to return the nearest E96 value of an input. Due to the strict logarithmic spread of the E96 values, that was very straightforward. To do the same with the E24 series and lower, there are values that do not follow the pure logarithmic spacing, and those exceptions will need to be handled in the code. Let's start by looking at the E3 series, which is rarely used. The second value of the series comes out mathematically to 4.6, rounded to the one trailing digit. However, the second value in the series is a tenth higher at 4.7. Who knows why, but I surmise there were some manufacturers of components that made components with values of 4.7 and thought it was close enough to just go with 4.7. Here's the E6 values. The 4.7 is used in it as well, and the third value mathematically comes out to 3.2. Just like the 4.7, it's increased by a tenth to 3.3. The E12 series has the two exceptions from the E6 series and adds 3 more. Now there's 8.3, which is reduced by a tenth to 8.2. That seems really odd, but then again, I suspect that it was due to include high volume part values that already existed. The E24 series has all the exceptions from the E12 series and adds 3 more. I'm guessing the added exceptions were adjustments to make the values around them more uniformly spread across the total of 7. In the code, this can easily be accomplished by case statements, adding a tenth to all 7 of these and subtracting a tenth from the 8.3. The E48 series is mathematically pure with no exceptions. It only has 3 values that are the same as the E24. The E96 series has 6 values that are the same as E24. The E192 series is mathematically pure with one strange exception. The calculated value of 9.19 is increased by 1/100th to 9.20. Okay, let's code this thing up. I'm calling the function E-series. The first argument is the input value. The second is the series number. I made it optional to set it at a default of 6. I'll dimension a 2D array called value steps for each of the 7 series as integers. The first value of the array is 3 for E3. The rest are the E numbers respectively. Notice the 6th is 96. I believe the majority of the use of this function will be for 1% resistors using the E96 series. Therefore, using the function without a series argument defaults to E96. Another thing we need to do is determine how many digits to round. If the series is greater than 4, or E24 or higher, I set the round digits variable to 2. Elsewise, it's 1. The code for computing the closest value is the same as before with the E96 series, except that instead of hard coding a 96 here, I use the value steps array variable that is of the applicable input argument series. Next is a set of case statements that adds or subtracts the appropriate values. There is actually a value of 3.2 in the E192 series, so 3.2 only needs to be increased if the series is less than E48 or 5. Then scale the base number back up to the input value, just like we did in the E96 code. Here's the code all together. I've provided a link to the code in the description below. Here's the code in the VBA module window. There's an input at the top and then the result for each series, E6 through E92. Thanks for watching. Please click the like, subscribe, and notification bell so you don't miss any upcoming content.